Hello. 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 Am I audible?
Yes, sir.
Okay. Okay. Great. So, good evening to all of you. Uh, so today's session is about it's nothing but open session of week 9. Okay. So, okay. So just give me 1 minute. Hello. Okay. So meanwhile, every one of you have covered the lecture video of week 9.
Yes, sir.
Okay. Great.
Yes.
So how is that? I mean, is it do you feel it's a difficult or easy?
The cumulative frequency was a tough, but I cleared it in afternoon.
Sorry, can you repeat? I did not get your point. Can you repeat?
So cumulative frequency was a little difficult, but I cleared it in the afternoon.
Okay, okay, okay. Great, great, great. Okay, so what we'll do? Okay, so we'll cover each activity. Okay, that will be fine, and we'll discuss if any one of you have doubt related to that lecture video and or any activity or a practice question. Will that be okay for everyone?
So
Yeah,
please
yeah.
explain the concept of discrete and continuous random variable.
Okay, okay, okay. So let me define first discrete and continuous random variable. After that, we'll proceed further. Okay. Okay. So let me share my screen. Okay, so anyone who can tell me what is the meaning of random variable, first of all? What do you understand by the random variable? Any one of you?
Sir, like when a random experiment is conducted,
Okay.
outputs are provided.
Okay.
On these outcomes, sometimes we are not interested in the outcome itself, but the frequency of the outcome. So that's
Uh,
why we use random variable to describe the outcome itself and find the probability of its frequency.
yeah, kind of. Basically, suppose let me give me example. Suppose I'm rolling a die. Okay. Suppose I'm rolling a die. So rolling a die or rolling a die, let's say like, two times. Okay, two times, three times. So it's possible. So this is the something random experiment, right? Correct. So what basically what is the funda behind random variable? It's like suppose I'm not interested to get all the outcomes, but I'm interested to know some of the outcomes. Like suppose I'm interested to know difference between numbers on two dice, or let's say I'm rolling two dice. So difference of the numbers on the die, let's say it's a two. Okay. So I will define my one random variable x, which will take the difference between I mean outcomes of the die will be difference will be two. So what should be the outcomes? So it can be 3-1, correct? It can be 4-2. It can be 5-3, like that. Okay, are you getting my point? So we are not interested in all of the outcomes. We are interested in the sum of the outcomes, while probability experiment or random experiment we are performing. And more formally, we can say it's a real valued function basically. Okay, defined on the sample space. Real valued function defined on the sample space. This is why. Suppose I roll the die two times. So what will be the sample space? There will be total 36 outcome. Correct? 1 1 2 1 6. Then 6 1 2 6 6. Correct? Am I right?
Yes, sir.
Okay. So my random variable is nothing but is kind of real valued function. Okay, it can take any real value which is defined on my sample space. Okay, are you getting? So basically I rolling a die, correct? I rolling die two times, I can get any of the this 36 outcome. I'm defining my random variable x such that sum of the outcomes are, let's say sum of outcomes are let's say 5. Okay. So what will be the what value x should take here?
1 and 4,
1
4
4,
and 1,
2 3,
2 3,
4 1. Correct. 3 2.
3 2,
That's all right.
3. Yeah.
Okay. So similarly, you can define your random variable. Now, this random variable have two types. One is discrete random variable and another is continuous random variable. Okay. So any one of you see, I think in week 2 and no, I think in week 1 it's there is discrete data and continuous data, right?
Yes, sir.
Correct. So what is that?
Discrete data, we could count the discrete data, and
Okay.
continuous data we had to measure the data.
We have to measure the data. That's the basic difference. Okay, that's an important also. So in continuous data, it can take also any value between a given interval. Correct. And
Yes.
discrete data, it will take distinct value. It will take distinct value on, let's say I'm saying it can take distinct value on real number line. That means distinct value means what? I can count, right?
Yes, sir.
Let's say it's a 1, it's a 1.5, it's 2, it's a 2.53, 4. So what is discrete random variable or discrete data means it cannot take any value between let's say I'm considering the interval 3 to 4. So it will not take any value between this interval. It's taking distinct value. It's taking 3, it is taking 4, it is taking 2.5, like that. Okay. While continuous data is something, continuous random variable something we cannot count. Okay, we have to measure, and it can take any values between a given interval. Let's say I'm saying this is the, let's say 2, this is 4. So if it's continuous data, then it can take any value between these two values. Okay, idea, you are getting the idea?
Yes, sir.
Okay, so let me give you some examples. I think it will clear, it will give you a clear idea what is the discrete and continuous. Tell me. So I will take the example. You have to tell me what should the answer. Let's say I'm saying number of students in a class.
Discrete
That's
random
discrete, sir.
variable.
That's discrete.
Yes, sir.
Yes, sir.
Why?
Because we
Because
can
we
count
can
those.
define that number.
We can define
We
and we
can
can
count
count,
it
right?
actually. We can
Correct.
count, yeah.
Okay. Let me take another example. Let's say number of attempts to clear an exam.
That's again discrete, sir.
It's a discrete, correct? Because
Yes,
I
sir.
Yes,
can
sir.
count, right? 0 attempt, 1 attempt, 2 attempt, 3 attempt, like that. Okay.
Yes, sir.
Suppose I'm saying time taken by a student to complete an exam. So it's a
Continuous.
Oh,
discrete
yeah.
or continuous?
Continuous.
That is
Continuous.
continuous, sir.
Why continuous? Because I'm
Because
taking,
Because it
okay,
can be
okay,
0 to end of the time, yeah.
okay. So I can say 1 hour, 2 hour, 1.5 hours. So why not discrete?
so we
Because
actually
we,
don't know which value will it take, because of, suppose the exam is 3 hours, so
Hmm.
it can take any value from 0 to 3 hours.
Correct, correct, great. And
But
I have
sir,
to measure, right? I have to measure in
sir,
hour and minutes,
Yes, sir.
whatever, right?
excuse me, sir.
Yeah, yeah, yeah.
Sir, but as you said, after measuring it, we'll get a discrete value, right? Like 1.5, 2.5,
No,
1.25,
no,
like
don't consider it, because see, I'm okay. So that's Chetan said correct, because suppose exam is of 3 hours exam. Okay, so a student can take any time between 0 hours to 3 hours. He can take 1 hour 15 minutes some nanosecond, then second and nanosecond, right? It can take any value. So it is like that. It can take any value from 0 hours to 3 hours, and you have to measure the time. You are not counting the time. Okay, what you are saying, you are counting the values. Okay, but
counting. I get that, but can you please explain the other concept that you are telling?
see, counting means what? So it cannot take distinct value on real number line, first of all, continuous. And you have to measure. You don't there is no need of counting. Means let me take another example. Let's say speed of a vehicle. So you tell me whether it's a discrete or continuous and why.
Sir, discrete, maybe.
So why discrete?
Because like 35 miles per hour, 45 miles per
Okay,
hour.
let's say 35 kilometer per hour. So you are counting the speed or you have to measure the speed?
Sir, we have to measure.
So that's why it's a continuous random, not continuous data.
Okay, sir. So only difference if we have to measure.
Yeah, it's a basic difference. And suppose, see, it's not like you said just 35 kilometer per hour. So suppose I have limited the maximum speed. Let's say I have limited for maximum speed for a car. Let's say 60 kilometer per hour. Okay. And so if there is a car running on the road, so it can take that speed can be any, I mean, that value can be any value from 0 to 60, right? Any value. It can be 15.32 kilometer per hour. It can be or not. It can be any value from 0 to 60. It can be 30 kilometer per hour. It can take any value between these two values. Okay. And basic main funda is you have to measure, you cannot count. Okay. Let me take another example. Suppose I'm saying height of a person. What is this?
So since we have to measure it, it's
Continuous.
Continuous. Correct. Weight of a person.
Continuous, also continuous.
Correct. Because you have to measure in kilogram and all things, right? Let's say I'm saying, let's say number of spelling mistakes in a report or in a page. So what
Discrete.
is
That's discrete, sir.
Discrete.
That's
Correct.
discrete.
So now it's clear. It's a
Sir,
discrete
but
and
the
it's
height of a person, that can be discrete, right? Maybe we are measuring it, but it's a definite number, right?
no how.
Height can take,
Suppose,
suppose, go ahead, Anshul.
Yeah, please go ahead.
suppose,
Hmm?
see, sir, there is a person whose height is 6 feet.
Hmm?
So that's it. I mean, it's not changing. It's fixed
So
6
don't
feet.
okay. So listen to me. Don't consider only one particular value. Suppose you are saying you
Okay.
have your height of two persons, and you are saying one height of one person is 6 feet and height of another person is 5 feet. You are saying it's a discrete. How?
Yes, sir.
First of all, you are counting these values. Okay. But for the height, you have to measure, right? And suppose
Yes,
there
sir.
is a group of 10 to 50 persons, okay, of a particular age, let's say 20 to 30. So height of person can take any value, right?
So
It can take any
also,
value. Yeah.
when
Yeah.
we're measuring height, we are
So
rounding
okay,
off the errors.
yeah,
Two
that's all.
people, two people with same height, 6 feet, does not mean that they actually have same height. There can be minor differences. So it's not
yeah,
actually taking discrete values. It's
okay.
taking
That's
continuous.
a different thing. That a different thing. You are right. But basic difference is you have to just be clear in discrete data. You have to count the thing, and in continuous you cannot count. You have to measure.
Measure.
There
Yeah.
is measurement. Okay. Now is it okay?
Yes,
Okay.
sir.
So okay, great. Okay. So let me go. I think activity lecture wise will be okay for everyone. In
Yes, sir. Lecture wise will go.
okay, so
Lecture
in
wise will
lecture,
go.
okay, so in lecture 9.1, any one of your doubt or in activity 9.1? Okay, so what should be the answer for this first?
A
A
real
random variable
valued
is what?
function defined on the sample
Sample
space.
space, which I have discussed just a few minutes before. That's correct. What should be with this one? Any doubt? Okay, so any one of you have doubt in this activity?
No, sir.
Okay, so let's go one by one. What should be the range? So
Sir, I have
question is,
1, 2, 3, and so on.
okay, one second. So let's go one by one. So range of okay. So what should be the answer for this?
One, two, three. Third option. I
Option
think.
3.
Option 3. Why not option 4? What's the wrong with option 4?
Because of sir.
We
Because of zero.
cannot have head with 0 tosses.
Correct. Correct. Suppose instead of tosses, it's written a number of heads, then it can be 0, right?
Yes, sir.
Yes, sir.
Okay. So be clear with the statement. Great. Great. You are getting the concepts. What about this one?
Second. No. Last. Because of 2, 3. When we take out ace.
2, 3, 20.
Since here it's written assume ace carries 1 point. Okay. So what we are doing here? So what is the experiment? We are drawing 2 cards simultaneously. Correct?
Yes.
From
Yes, sir.
a well shuffled deck of cards. It says each of the face card carries 10 points. Okay. Okay. So just give me 1 minute. Yeah. Hello. Hello. Am I audible?
Yes, sir. Yes, sir. You're
Yeah.
audible.
Yeah.
Yes.
So we were at okay. So okay. So what? Okay. So what? How many face cards are there?
12 face cards.
12 face cards. Okay. So and each face card are carrying 10 points. Correct.
Yes, sir.
So
Yes,
that
sir.
means what? If you okay, and the ace cards are carrying it carries 1 point. So if you draw 2 cards, so maximum number will be what? 10 plus 10. That's 20.
20.
Yes, sir.
And minimum number should be
1 plus 1.
1 plus
2.
1. 1 plus
That's
1, 2.
that's okay. Okay. So tell me answer of the question number 4.
64, sir.
This is my doubt.
Okay. So who said 64?
I did, sir.
Chetan. Okay. Great. So can you tell him? I
Sure,
will
sir.
write. Okay. I
Sure.
will write.
Sure.
Just tell him. Okay. Please.
So if I what I did, sir, from 1 to 10 we have values as per numbers. So ace carries 1, 2 carries 2, 3 carries 3, and so on till 10. And also king, jack, and queen also carries 10. So for each for each color and what should I say, for say spade, for spade we have for
there are 4 suits.
suit for 4
Yeah.
suit. For each suit we'll have 4 cards carrying 10 value
Correct.
10, right?
Correct.
And for some to be 19, it should be 1 9. So 9 should be the one card and 10 should be the other. For 9 we have 4 choices for choosing 9, because each suit will have 9 1 9. We'll have 4 choices, and that 9 can be paired with 16 other cards, 16 other cards carrying value 10. So it would be 16 into 4.
Great, great. So is it clear now?
No, sir.
Okay, not clear. Okay, so tell me, what is the x? It is asking x for should be 19, correct?
Yes, sir.
Okay, how will you get the 19? Some on 2 cards.
Yes, sir.
For the first card, what should be? It can be 10. It can be 9.
Yes, sir.
Correct. So there is one card with number 9 and 4 cards in number with number 10.
Okay.
Correct. In one suit, means in spade or in club,
Diamond, heart.
diamond and heart, right? So let's consider for the spade. For the spade, how many way you can
13 by 13, 30 by.
no. In how many way you will get 10?
How many way?
4. I'm okay. Are you getting my point? See, for being sum should be 19 on both cards. For the first card, it should be 10.
Yes, sir.
Okay. So in how many way you will get 10? That's what I'm asking with you.
King, queen, jack, and 4, I think.
4. Okay. And for 9?
Or 9 in a spade.
Okay. To be okay. So let's consider. Yeah. So in 9, in how many ways you can get 9?
4 ways, sir.
4 ways. Because
In
9
spade,
can see 9 can be from any suit, right? It see
Yeah.
that 2 cards can be from any suit. Okay.
Okay.
Are you getting? See.
Yeah.
Yes.
Yeah.
See, in a single spade, is saying ace is taking carries 1 point. Okay, and there are cards which are carrying 2 to 10. Correct.
Okay.
And then all the face cards king, queen, jack also carries 10 points. Okay, this is the my question. Correct.
Okay.
So there is one card with number 9. Correct. So for getting some, let's say for 10, let's say for this is the first card and this is the second card. Okay. So
Yeah,
for
got it, sir.
to get the 19, what should be the how many? So there are 10 total 10 sorry 4 cards in a single suit, right?
Okay.
Okay. Okay. So let it be. Okay. Let it be. Okay. Let's consider. So this is considered. Suppose this is for spade. Okay. The same thing will be for club. One means ace here. Okay. In the for this particular. Then 9. Then 10. Then king, queen, jack. Correct.
Okay.
And
Then
for
go to the power 4.
For the diamond, 4 is for 4. Okay. For the diamond, again same thing.
Yeah.
Correct.
Yeah.
And for the heart, again same thing.
Yeah.
Correct. So to get the sum as the 19 on 2 cards, so that should be one card should be 10 and one card should be 9. Correct. So how many 10s are there? 16.
Yeah.
4, 4, 4, 4. Correct. 16.
Yes.
And for getting the sum, how many cards of 9 is there? 4.
4 cards.
This is 64.
Yeah.
Yes.
Got it.
Sir,
Is it clear?
Yeah. Now it's
sir,
Yeah, please go ahead.
sir, why don't we consider order here, sir? I mean, why we
What?
can take 9 and 10 or 10 or 9 either
Yeah,
way.
no, in either way you will get 19. So, okay.
Means the outcome will be double, na, sir. If we consider if order does not matter, if matters.
So what's the point of order matters here? Okay. So I'm saying I have drawn 2 cards out of 52 cards randomly. Okay.
Yes, sir.
And then I want to know whether sum is 19 or not. That's all.
Okay.
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 Yeah. Great. Okay. So what about question number 5?
0 to infinity.
Closed interval.
0
Saying
to
a random
infinity.
variable x is defined as the time in hours from now until the next rain occurs in a city. What are the values x can take?
0 to infinity.
First one, right?
Yes,
We
sir.
know we don't know the upper limit. I mean the next time, right? It can be anything. Okay. What about question number 6?
Negative 3,
Minus
81.
3, minus 1, 1, 3.
Yeah,
Okay,
third
great.
option.
Okay, so all the questions is clear, or should we do any question? If you doubt, so we'll do.
Question number,
Or
sir,
else-
question number 9. Question number 9.
Question number 9. Before that, is it okay for everyone?
Yes, sir.
Yeah.
Okay, so question number 9. Okay, so can you tell me? Let me read the question first. An insurance salesman visits up to 3 clients each day. Okay, hoping to sell a new policy. He stops for the day once he makes a sales. Okay, each client independently decides whether to buy a policy. Okay, 10% of the clients purchase the policy. That means, what is the percentage of clients who did not purchase the policy?
0.9, 90%.
90%.
Right? That's clear. Okay. So I'm defining random variable x as the number of sales he made in a day. Correct? So question is find the value of x equal to 0. Okay, so what is the x basically? Here. What is the x represents? Let's write down all the things. Number of
Sales he made.
sales he made in a day, right?
Yes, sir.
In a day. What is the things are given in my question? He visits 3 clients each day. Correct?
Yes, sir.
Okay.
So he visits 3 clients each day. Correct? And what is the probability for purchasing?
10%.
0.2, 0.1.
10%. Correct?
Yes, sir.
Yeah, given.
And what is the probability? I mean, that means, see, that means 10% of the clients are purchasing the policy. Correct?
Yes, sir.
That means
Okay.
what? 90% of the clients
Will
will
not
not purchase
purchase.
the. Correct?
Okay.
So far, so good.
Yes, sir.
Yes,
Now,
sir.
question is asking what probability of x equal to 0. So what is the x? X means
Nobody
x
purchased.
represents
Number of sales.
number of
0.9.
sales. So
Hmm.
probability x equal to 0 means there is no sale in a day.
Yes, sir.
While that insurance
Insurance.
salesman visits the 3 clients each day. Correct? But
Yes,
in
sir.
a day, I'm saying there is no sale. Correct? That means if x equal to 0, then I can write not any sale in a day.
Yes, sir.
Correct?
Yes,
How many clients he so
3
he
clients
visits
per
3
day.
clients, right? That means none of the clients purchase the
Yes, sir.
policy, right? That means, and what is the probability for who do not purchase the client?
90%.
Policy
0.9.
90%, right? So 0.9 for a single client, 0.9 for the second, 0.9 for the third. So you
Oh.
will get, I think it should be 0.81 into 0.9, 0.729 is the answer.
Yes, sir.
Okay, so you can check from here 0.729. Okay, so let me check the answer. Okay, so 0.729 is the in this range. Okay, is this clear now?
Yes, sir.
Great.
Sir, could
Okay,
you
so,
open the board? Board?
This one?
Yeah. Just wait a minute. Yeah.
Okay.
Okay. Clear, sir. Clear.
Clear? Okay, great. What about question number 10 or 11?
No.
Both are clear?
Yes, sir.
Yes, sir.
Both questions are clear for everyone? Okay, so okay. So tell me why is the answer of question number 10 is 0?
So the random variable x says
Hmm.
that the number of house he delivers the right post, right?
Correct.
So
Great.
if we say that he delivered he has three posts to deliver, and
Mhm.
he delivered two of those posts to correct address, then the
Mhm.
third post will also be automatically delivered
It's
to the
automatically, it's
correct
an
address.
inbuilt kind of thing.
So
It's
we
a
will
default.
have the probability of this will be, sorry, the number of this will be
0.
only one case would be there, that
Correct.
x
So in a
equal
way, your x will
would
take
be.
what values x
Hello,
will take?
am I audible, sir?
Yeah, you are audible. Hello.
Hello.
Hello. Am I audible?
Yes, sir, you are audible.
Yeah. So in a way, yeah, you are right, because I'm saying x equal to 2. That means he posted the uh, I mean, what was the question? Yeah. So he delivers the right post in 2 houses. That means if there are total 3 houses and he delivers correct post in 2 houses, that means third will go automatically correct, right?
Yes, sir.
So there is no anything which in which x will take value 2. Okay. So there is only 3 possible case. X will take 0, 1,
1
and
or 3.
means none of the house will get the correct post. Only one house will get the correct post, or all of the house will get the correct post. Okay.
Okay, sir.
Okay. So question number 4 is sorry, not 4, 11 is clear to all of you.
No, sir. 660.
Yes, sir.
Okay. So what is your okay? What? Yeah, one. Okay. Yeah. Please go ahead. Please go ahead. Hello.
Yes, sir. Yes, sir.
Yeah. So you have doubt.
Yeah.
Okay. So can you tell me what? How did you approach to this?
Um,
Just
sir,
okay. Feel free to say. Not hesitate. Yeah. What people will
yeah,
think. Don't worry about this
it's
kind of
okay,
thing.
sir.
Yeah.
Yes, total choose is 20 out of, we are taking 5 cardinality of x equal to 2. The random variable x is defined as the number of girls is chosen student, and the cardinality is x equal to 2. Sir, so that means the two we chose as 2 girls, no, sir,
Mm-hmm.
out of 20.
So out of 20 or out of 10?
Okay, okay.
Okay. So, okay.
Out
So,
of 10, sir.
okay. So there are so 4 students we have to choose, and there are 10 boys. Okay. And 10 girls. Okay. Just go statement by statement. If you write down each statement, you will get the clear idea. Okay. What is your random variable x? I'm saying my x represent as the number of girls, right? Correct.
Yes.
Number of girls in chosen students. And how many students we have to select or choose? Total 4, right?
Yes.
So cardinality for x equal to 2. So x equal to 2 means what? We are selecting or we are choosing 2 girls.
And 2. Oh, yeah.
Okay. So in how many way you can choose 2 girls?
10C2.
10C2, because I have 10 girls, right?
Yes.
And since we have to
10.
select the total 4 students, so if we have chosen the 2 girls out of 10, that means we have to choose the remaining 2 should be the boys. Correct?
Okay. 10C2. Yeah.
Okay. So you have to solve this. You will get 10 factorial, 2 factorial, 8 factorial. So it will be something will be 10 into 9 into 8 factorial. So 2 into 8 factorial will get cancelled out. So it's a 2, 5, 10. So 45, but 45 times 45, because 45 will be this. Okay. So just compute this value. 45 times, I think it's 2025 is the answer.
225. Correct, sir.
Correct. So idea, did you get the idea?
Yes, sir. Yes.
Okay, great. Yeah, 2025 is correct. Okay, so any doubt in activity 9.2 or lecture?
No, sir.
Okay, so what should be the answer for the first question? Here, x is the
Both are continuous.
error in the measurement of length. Both are continuous.
So
Yeah.
X is continuous and the number of imperfection that is Y would be discrete.
Correct, because we are counting the number of imperfection, number of errors, right?
Yes, sir.
Okay.
Oh yeah,
There is-
yes, sir.
There is one error, there is two error kind of thing. But x is the length. We are measuring the length. That's why it's a continuous. And since we are counting, so y should be the your discrete random. Okay. What about question number 2?
X takes the values.
Means what is your
Ne-
x? X is
number
the
of
number of
customers
customers entering the shop every day, hour in a day. That
Yeah.
means x
discrete
Discrete
random
value.
variable.
Oh.
So it
Okay,
would
so-
be natural
I
numbers including 0.
0, yeah.
this one.
Second one,
Yes, sir.
yeah.
Okay. And why is the what? Why is the
Continuous.
time between?
Continuous.
The
Continuous
right?
variable.
So it's
Yeah.
a continuous variable. Okay. We'll see the answer first. Okay, let's see the answer. After that, whether discrete and continuous is clear for everyone. Okay, that's correct answer. Correct. Great. Okay. So what about question number 3? Okay. Any one of you have doubt or this one?
Yes,
is,
sir, I have doubt.
Okay. Okay. So had you tried this one?
Yes, sir, I tried.
Okay. So what was your answer? How did you approach? Tell me first, because so that I can know. Okay. How did you try it and where you are getting difficulty?
Actually, sir, I tried like 10
Yeah.
blue and 5 red balls. So we
Mhm.
have 15 balls.
Hmm.
And then,
Okay. So. Mhm.
mhm.
Yeah. Please go ahead.
Yeah, if both, he's saying x is equal to, if both are same color, then 1, and both are different color, then 0. So we need to find
Mhm.
we need to find out what's
The
that?
answer is 125 for
Yeah.
X equals to.
One second, Chetan. One second. Let's explain the Indal first because. Okay.
Actually,
Okay. Yeah. Indal,
yeah,
please go ahead.
I'm not, my answer are not correct, but I'm saying my method.
Mhm.
Then we need to find out the result is x equal to 1. So so we need to just like NCR formula apply. I apply NCR formula.
Okay, what's the okay? Okay, so just go by the simple. Okay, one more suggestion from my side. Okay, so if you are reading a question, okay, so don't think immediately I have to apply some formula. I mean, don't say permutation combination like it. Just read the question. Try to think what the question is saying. Okay, do it in a simple way. If you feel formula can be applied directly, then apply it. Okay, like this. See, what the question are saying? There are 10 blue. Sorry, just go statement by statement. Things will be clear. There are 10 blue and 5 red balls in a bag. Okay, just write the things. There are 10 blue and 5 red balls. Correct.
Okay.
A ball is randomly drawn and its color is noted and put back in the bag. Correct. Again, second ball is drawn and its color is noted. Okay. So X, I'm defining my random variable as it will take value 1 if both balls are of same color, if both balls are of different color. So what's the mean of same color? I mean, I will say X will take value 1 when suppose I draw a ball, suppose it's blue, then I put it back again in this bag and again I draw and again I draw a blue ball. Then X will take value 1. Suppose I draw first blue and then put it back in the bag again and then draw another ball and I got red ball. So then my X will take 0. There will be a lot of cases like this. Okay. So this is my question is saying. So it's saying how many draws for X equal to 1. That means there are how many ways in which I will get X equal to 1. Correct.
Okay, sir.
Okay, so there are two cases. either both balls should be blue or both balls should be red.
Yes.
Okay. In how many way you can get the first first ball as a blue?
Is 10C1?
10C1. Okay, that's 10, correct? And I put it back again. Now, in how many way you can get the second ball as a blue?
10.
10 also.
10, because okay, we have put it, we have already okay, we have put back in the
Replace.
bag. Okay,
Replace.
it's a replacing things. Okay, so okay, in how many ways you will get the red ball?
5C1.
5C1. In how many ways you will get the second red ball?
Also 5C1.
Okay, so since these are OR cases, it can be this one or this one. Okay, so that means this
Yeah.
case plus this case, so 100 plus 25, so 125. Okay,
Okay.
is it clear? Suppose
Yes,
we
sir,
are
yes, sir,
not
it is.
replacing back the balls, then what we will get? 10 into 9 like
9.
that. Okay,
Yeah.
okay, now is it okay?
Yes, sir, it is okay.
Yeah. What about question number 4?
Actually,
This one question was okay for everyone.
Yes, sir.
So should we move to the next?
yes, sir, yes, sir.
Okay. Okay, so there is again some discrete and continuous. Okay, so tell me what's there is axis. The axis, the time to the failure of an automobile.
Continuous and then we
Continuous, right? Direct. And what about question number 2?
It's also continuous. I think continuous.
Continuous and
X takes
0
value
to
0
5.
to 5
0 to 5.
0 to 10. How?
because there are smaller
This-
parts
Yeah,
and
two part.
Okay.
Yeah, yeah.
not
2 part.
not two part because there's smaller part.
Yeah,
Uh,
smaller parts. And we are splitting in 2 parts also.
Yeah.
After that, we have to consider this. Okay, so tell me about this one. What is the length of the phone call?
Continuous random
It's a
variable.
That's
continuous, right?
continuous variable.
And we have to select the discrete. Okay, now I think you will get more clear idea. What about number of the customers visiting every hour in the shop?
Discrete.
Discrete, sir.
Continuous?
Discrete.
It's a discrete. I'm interested to know number of customers. I can count one
Oh,
customer,
yeah.
two. Correct? I'm not
Yeah,
interested in hour. I'm interested in customers, right?
Yes, sir. Sorry.
What about amount of milk? It's a discrete.
Continuous.
Continuous.
This is
Continuous.
continuous.
Number. Why? Because see, if you say 1 liter milk, one is a discrete. No, don't go like that. Milk is something you have to measure, right? You cannot count.
Yeah.
Correct. So what about this number of accident taking place every
Discrete.
hour on
That's
Discrete.
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 travel time from your home to office?
Continuous.
Continuous.
Time
Continuous.
interval between 2 successive goals?
Continuous.
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 Proportion of people?
Again continuous.
Okay, great. What about question number 4?
The number of values X can take is 21 and X is a discrete variable.
Discrete.
Okay.
Hmm.
Is it okay for everyone? Was it
Yes.
saying something length of a hypotenuse of the right angle triangle whose other 2 sides are determined by the roll of the 2 dice. Okay. So roll of the 2 dice means both sides can be other 2 sides base and height can be outcomes of the 2 dice, right? It can be 1 1 1 2 like this. Okay,
Yes.
up to 1 6. Okay, so these things you have to find out. Let's say it's a x, so it can be 1 1, it can be 1 2, it can be 1 3. Okay, it can be 1 4 like this. Okay, so similarly you have to think. Okay, so why x will take 21? Why not x is 36? Because if I roll the die 2 times, I will get 36 outcomes.
Sir, if we take 36 outcomes and we remove the duplets, we
Correct,
get
correct.
we remove we have 30 outcomes left. and for all 30 left outcomes, we'll have some similar outcomes which will give us same result. So we
Correct,
divide
correct.
it by 2 and add again those 6. So it becomes 21.
So basically what happened, if you take base as 1, sorry, height as 1 and base as 3, or base as height as 3 and base as 1, you will get hypotenuse as the same, right? Square root of 9 plus 1, that's you will get square root of 10, correct?
Yes.
For 131. So these duplicates will get cancelled. So in a unique way, you will get total 21 value. Okay. Okay, let's move to the next. What about this one? Okay, so tell me, before going to the question, any one of you can tell me what do you understand by meaning of the PMF? What is this basically?
So distribution of probabilities of a random variable.
Okay. Good, good, good. Anybody else? So see, yeah, you are right. So it's a full form is probability mass function. Okay, kind of thing. So okay, so what's the PMF said means suppose it's saying so suppose my x is taking some values, let's say x1, x2, and xn, correct?
Yes,
And
sir.
suppose I'm interested to know probabilities to each x size. Okay.
Yes, sir.
So basic funda is my x is the discrete random. PMF is defined for the discrete random variable. So x is the discrete random variable, and x is taking some values. Let's say x1, x2, xn. So I'm interested to know the probabilistic behavior for each values of x. Okay. What is the probability for x1? What is the probability for x2? What is the probability of when x is taking xn, right? So it's a kind of interested question, right? Suppose I'm saying my random variable x is taking some value, so I may be interested to know what is the probability for those things, right? Suppose I said I roll the die 2 times and I'm defined x as the getting of sum on the both sum should be 7 on both dice, correct? So if some are the same, then I may interested to know what are the probabilities for that. Okay.
Yes,
Are
sir.
you getting my point?
Yes,
So
sir.
this is something
sir.
called when I'm interested in the probabilistic behavior at each values taken by my random variable, that's called the something PMF. And there are two basic important properties for being a PMF. What are these two?
So the
Probability
probabilities
Sum
cannot be
should be equal
negative,
to 1.
and the
Correct.
sum should be equal
0.
to
Correct. Not summation of all the probabilities should be equal to
1.
1.
1. I think continuous is not in this stats one. I think it's you will study in week 12 maybe. But while okay, so let's do for the discrete first. Don't, otherwise you will get confused. Okay, so this is something. These are the PMF. This is the PMF, and this is the basic properties for being a PMF. Okay, so tell me what is the uh, any doubt in activity 9.4 in any question?
No, sir.
No, sir.
Question was clear for everyone, or should we do one problem?
So let's do it, sir.
Okay, let's do it first. Okay. Okay, so in the first, it's saying 1, 2, 3, 4, 5. Okay, so x is something taking value 1, 2, 3, 4, 5, and probabilities are associated with each xr. It was 0 t by 2, 0 t t by 2, 4t square, and 3t by 2. And question is asked about what is the probability of x equal to 5. So I can directly say it's a 3t by 2, but I don't know the value of t here, correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
So how will I compute the value of t?
Sum
I
of
have
all
to
the
use the
probabilities equal to 1.
correct.
Yeah.
Correct. I have to use the property of being a PMF. Since if it is PMF, then summation of all the probabilities should be equal to 1. Okay, so that means summation of all the probabilities should be equal to 1 means what? That means 0 plus t plus t by 2 plus 4t square plus 3t by 2 should be equal to 1. Correct?
Yes, sir.
So if you solve, you will get something 40 square plus t
3.
plus this will be 40 by 2 equal to 1. So I will get 40 square plus t plus 2t equal to 1. So I will get 40 square plus 3t minus 1 equal to 0, right?
Yes.
So I have to solve this quadratic equation. I will get 40 square plus 40 minus t minus 1 equal to 0. So 40 I can take as a common. I will get t plus 1 minus 1 t plus 1 it will be equal to 0. So it will be 40 minus 1 and t plus 1. So what are the possible values for t? Minus 1 and t is equal to 1 by 4, right? So which value we have to take?
1 by 4.
1 by 4.
Why not
One by-
minus 1?
Because we cannot have probability in the negative.
Correct, correct. If you take the t as the minus 1, this probability will be negative, but this is not a property of the PMF because probability should be greater or equal to 0. So we have to take the value of t as 1 by 4. So it will be 3 by 2 into 1 by 4. So 3 by 8 is the answer. Is there any option 3 by 8? Okay, so this is the
Yes, sir.
Third
Is
option.
it okay for everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Any doubt in any question of this activity?
Can we look at the sixth one, sir?
6 1 6 1 6 1. So
Six
probability
and
mass
seven.
function of a discrete random variable x is given by So probability of x equal to x is given by k times 2cx 3c 3 minus x for x equal to 0 1 2. Okay. So since it's a PMF, so we have to find out the value of k, right? So that means what?
Yes, sir.
For 0, what it will be? K times 2c0, 3c3. Okay.
Yes, sir.
Because x is taking value what? 0, 1 and 2. For x equal to x, this is the PMF. This is the probability. For x equal to 1, it will be k into 2c1, 3c2. Correct? When x
Yes,
will be 2, your probability should be k into 2c2 into 3c1, right? Since we have to find out the values of k, so sum of all the probabilities should be equal to 1.
Yes, sir.
This should be equal to 1. So k can take as a common. So what's the value of 2c0? 1.
1.
3c3, 1.
1.
And
2c1 will be 2. 3c2
2.
will be 3 factorial, 2 factorial, 1 factorial.
3.
So 3 plus 1 into 3, right? This should be
Yes.
equal to 1.
Oh, okay, okay. So that, I thought C is a constant, sir.
Sorry?
C is not a constant. Oh, I thought that C is a constant. So that's not a
No,
constant.
it's a
is it?
combination. It's a combination.
Okay. Okay, sir. That is what my confusion was.
No,
I
no,
thought C is a constant.
no, not a constant. Sorry?
And why, sir? There is, okay, that is 2C. Okay, okay. So got it. Thank you.
Okay, clear? What
Yes,
about
sir.
question number 7?
Can we do it?
We can do each week also. Okay, so can you tell me what was your approach?
1 second, sir. Let's see.
sum of the
I
probabilities
just
should not
did
be
it.
exceeding 1.
Okay, I think okay, you have done for the each option. You have not find out the table directly.
I got the answer, but that is wrong.
Okay, let's do by the concept. Okay, so by the options
Okay.
we can see we have to find the probability mass function, right? Now, what are the things in the question are given? Just write down all the things. It says a shipment of 20 similar computers to a retail outlet contains 3 defective computers. Okay, so let me add a page. Sorry, 1 minute. So out of this 20 computers, it's saying 3 are
So 3 are
defective.
defective.
That means what? 17 are non-defective.
Good.
I'm writing
Non-defective.
for
Yeah.
non-defective as ND. Okay, just ND treat as non-defective. And if a school makes a random purchase of 2 of these computers, that means he can purchase any computers out of, I mean, any
It's
2
20.
computers out of these 20, right?
Yeah.
Correct. Now, so
Yes,
it's
sir.
saying find the probability mass function of the number of defective. So since we are interested to know the probability mass function for the number of defective, that means I can define my x as the number of defective. Correct.
Yeah, sir. So,
Since
okay.
yeah, just think. Okay, so tell me,
Okay.
what
So,
should
since we are purchasing 3 computers, there can be 4 cases, right? Like
no, we are
no
purchasing
defective, 1 defective, 2 defective, 3 defective.
no, we are purchasing 2.
Yes, sir.
We are
0,
purchasing.
2.
School makes a random purchase of 2.
Oh, yeah. In that case, 3 cases, right?
Yeah, that's I was asking with you. What should be the absolute take values?
0, 1,
0,
2.
1, 2.
Correct, because we are purchasing in a total 2 computers, and X represents the number of defectives. So out of those 2 computers, 0. I mean, there's all can be non-defective, or
Yeah,
one
no
can be
defective, 1
defective,
defective, and 2
and
defective.
all can be defective. That means possible values X should take 0, 1, and 2. That's okay. That means we can see the option where 0, 1, 2 is there. So in the all options 0, 1, 2 is there. Now we have to check the probabilities. Okay, let's do. So what is the probability for X equal to 0? Okay, that means what?
Okay.
What is the
That
PML?
will
X
be
None of
equal to
is
17
X,
by
defective.
No defect.
0, 1 second, 0, 1, 2. So we have to find the probability of X equal to 1. So what is the probability for, okay, what is the meaning of probability of X equal to 0?
No
defect.
defective computer.
Okay, no defective out of
Computer.
2, correct?
Yes.
Sir.
So what should be the probability? What should be the total number of case for selecting the 2 computers?
17 C2 divided by 20 C2.
Total.
1 second. So okay, what is the probability? Basically, favorable case divided by total case. Okay.
Yes, sir.
correct, sir.
So what is the total case to select the 2 computers?
20.
DC2.
20 C2.
Because total, not don't go 70. I'm
Okay.
asking about total.
Okay.
I
Okay,
can okay, so I can select or I can purchase any 2 computers out of 20, right? This is
Yes,
my
sir.
total. What is a favorable? Favorable is I'm interested, no defective computers should be there. So how
Yeah.
many non-defective computers are there?
17.
17 C2.
70, right? So that should be
17 C2.
C2. Okay. So you have to solve this. I mean, after solving, you will get values. Okay. I'm not going to solve. Should I solve it or you will
No,
do it?
no,
it's
sir.
okay.
No, sir. Got it.
Okay,
Got
got
the
it.
fund. Yeah.
Okay. So what about probability of X equal to 1? Means 1 defective computers,
Yes, sir.
Yes, sir.
1 defective out of 2. Now, tell me, what is the total case for the 2 computers?
20 C2.
Yeah.
20 C2. That's
20
okay,
C2.
right? This is the total case. Now,
Yeah.
favorable case is saying 1 should be the defective. And
Yes,
how
sir.
many defectives we have? 3.
3
That
defective.
means 1 computer should be these 3 out
Yes,
of
sir.
these 3, and remaining
Yes, sir.
1 should be from non-defective, because
Yes, sir.
I'm purchasing in a total 2.
Yeah.
Correct? So if
Yeah,
I'm
sir.
purchasing 2, so one should be from here, one should be from here. As X will take the value 1, that means 1 is the defective. That means 3C1
3 into
into 17C1.
17 C1. Yeah.
Correct?
Correct, sir.
What about probability
Got
X equal to 2 means probability that all are defective.
Defective. Yeah.
What is the total case? 20C2.
3C2.
If all are defective, that
Yeah.
means
So
I have to
20
choose
C2,
the both to come from the this.
3
And
C2.
can I write down the also? This is 17C0. I mean, that
Yeah,
will be
sir.
1,
We
but
can
it's
write.
good to know. That means we are doing the
No, sir.
0.
Why should we write 17 C0? Because we are not even considering that case, right?
We are not considering. I have written just for a concept. Okay. Suppose I said probability X equal to 3. I mean, suppose we are purchasing 3 computers, then we have to consider this case also. Okay. So I will return for, okay. So just try to get the funda. That means we are choosing the 2 non-defective and 0 defective. Correct? That's all. Okay. Idea is clear. Just compute this value, you will get the correct option.
Idea is clear, sir. Thank you.
Okay, great. So let's move to the next activity. Okay, I don't know why it's not okay. Okay, so is there any doubt in activity 9.5 or is it okay for everyone?
It was okay, sir.
Okay for everyone?
So, sir, can we look at the third question, sir?
Which one?
The third one.
Third, let me see what is the third. An unfair coin is tossed thrice, and the distribution of number of tails. Okay, so if the same coin is tossed once, then
So
what is the
usually,
probability that
how to approach this unfair coin question, sir? Biased die, unfair coins. All this
okay,
kind of
okay. So what is the meaning of unbiased basically? Unbiased, if I'm saying unbiased coin or fair coin, these things are same. Okay. If I'm saying unbiased die or fair die, so it's the same. So what is the meaning is, suppose I toss the coin. Okay. So it's a kind, there is no biasness. It's unbiased, it's a fair thing. I will there is equal probability for getting head and equal probability for getting tail.
Correct, sir.
If there is some manipulation in coin, let's say side of head is I made as some heavier like that. Okay, so I mean any manipulation, any biasness is involved there. So if suppose I say probability of head is, let's say 0.6, so and probability of tail is will be 0.4. So I'm doing some unbiasedness, or sorry, biasness, right? I'm considering for head to be greater than tail. Okay.
Okay,
So
sir.
same is for die. If I'm saying I'm rolling a fair die or I'm rolling a unbiased die, that means I have to equal chance for getting 1, 2, 3, 4, 5, 6. Okay. For 1, I have 1/6 probability. For 2, I have 1/6 probability. For 3, for 4. Okay.
Yes, sir.
Is it okay?
Yes, sir.
Okay.
What would that be biased to 1/6 to 1, sir?
One by,
I mean,
okay, so
there is
bias
a
means okay.
probability of, yeah.
Yeah, so suppose I said for, okay, so I have done some manipulation. I said for getting 1, probability is 2/6. For getting 2, probability is 1/6. For 3, probability is again 2/6, like that. Okay.
Okay.
I have some manipulation. Okay.
Uh-huh.
So come to this question. It's saying unfair coin is tossed thrice. Distribution of number of tails. Okay. So if a coin is tossed thrice, okay, so it says if the same coin is tossed one, what is the probability of it will show head? Okay. So what is the probability? Okay, so it will show head means what?
No tail.
It's a no tail, yeah.
Okay. It will show head
Okay,
means,
the graph is for number of tails. So
yeah, graph is for number of tails. Okay, let's do. Okay, so we can verify one. Okay, we can verify one. So what is the x is taking the 0, 1, 2, and 3, right?
yes, sir.
So if I'm saying x equal to 0, that means no tail. No
No tail,
tails means
yeah.
what?
All
All
head.
3 are
It's
heads.
all head. Yeah.
All 3 are heads. Okay.
Yes,
Let's
sir.
assume for a head probability is p. Since it's a it's a unfair coin, I don't know the probability of head. If it's fair coin, then I will say probability of head is half. Okay. So I'm
Okay,
saying,
sir.
so let's assume probability of head is, I'm assuming as p. Okay. So all 3 are heads means what? Okay. So what is the probability of x equal to 0 is in the given?
0.027.
0.027.
0.027. So the x equal to 0 means all 3 are heads means p into p should be 0.027.
Yes.
So p cube should be 0.027.
Yes.
So can I write down this thing? This is same as 0.3 for 3.
Oh, yeah.
Yes.
So p should be 0.3. Okay.
Yes, sir.
So it's a unfair die. If it's fair die, then P should be 0.5 for
1
head
by 2.
and P should be 0.5 for tail also.
Yeah.
Idea is clear?
Yes, sir.
Clear, sir. Clear.
Okay. Any doubt for lecture 9.6 or any doubt in activity 9.6? Okay, so before come to this point, any one of you can tell me what is the fund of CDF? What do you understand by the CDF? Because if you go in the stats 2 after this things, in stats 1 it's also basically CDF, PMF, PDF, it is all things. PDF is for continuous runtime variable and CDF is defined for both. You will study for continuous also. So PMF, CDF is kind of plays a very important role in statistics. Okay, so try to understand what it. So any one of you can tell me what is the funda of the CDF?
For a particular value of a random variable, CDF is the summation of probabilities such that the values that x can take is equal to that particular value or less than that particular value. So it's like suppose my x can take 0, 1, 2, 3, 4 values, and someone asks me what is the CDF for 3. So that would be a summation of probability of 0, 1, 2, 3.
Correct. So if you go correct, great. So what is the full form of CDF? If you
Cumulative distribution function.
correct, if you will focus on the wording, so it's a cumulative distribution function. So if you go on the cumulative means, see in the PMF, suppose I ask what is the probability at x equal to a, correct? But in cumulative distribution function, suppose it's also possible I may interest to know the probabilities till a point, not at a particular point, right?
Yes.
Suppose I'm interested to know, tell me the probability x should be x should take the values less or equal to a. That means we have to accumulate. Okay, we have to accumulate all the probabilities less than or equal to this point. We have to consider all the probabilities. We have to accumulate all the probabilities till this point, not probability at a particular point. Okay. Since
Yes,
for
sir.
this example, suppose as Chetan you said, that's correct. Suppose I can ask what is the probability of x will take 1. Okay, but that's the not a CDF. Suppose I ask what is the probability x is less or equal to 2. Means we have to accumulate all the probabilities till this point. That means what is the probability at x equal to 0 plus what is the probability x equal to 1 and what is the probability for x is taking value. Okay, that is something CDF. In generally we define f of a is nothing but
Sir,
probability of
I
x.
have a question here.
Mhm.
In the same example, when x is equal to 2, probability of x is equal to 2,
Mhm.
when it reaches x is equal to 2, that value will jump into that next value, right? I mean, it will go to that probability of 2 and then it will move till 3, right? X is equal to 3, like that.
Can you repeat? Can you repeat?
Sir, when drawing the graph,
Mm-hmm.
see, for the value 2 in x-axis, it will from 1 to 2, it will be the same value, right?
Yeah. Okay. I will draw a graph. I will draw. One second. Let me write down the one thing. I'm assuming, let's say my discrete random variable is taking value 1, 2, 3, and 4, and probability at each exercise. Let's say for 1, it's let's say it's a 1 by 4. For 2, let's say it's 1 by 2. For 3, let's it's 1 by 8. So it's 1. 1 minus 2. So it will be 1 by 8, right? Just add
CMF will be PDF also, right?
So let's add this. This should be equal to 1. Is it 1? 1 by 8 plus 1 by 8, 2 by 8.
It is
So
1.
it's 6 by, yeah.
Correct.
Yeah, it's 1.
Correct.
Correct. Yeah. So suppose this is the PMF for my x is the discrete random variable. Let's define how to compute the CDF. Okay. So CDF is basically let's say fx or f of a. So we have to consider for all the points. Okay. Means suppose my x, okay, so this is x, let's say. So what is the probability x will take before 1 if x is less than 1?
0.
0, because x is taking the value from 1, right?
Yes.
Correct. Now, what is the probability when x will take from 1 and before 2?
By 4.
1 by 4.
Sir.
Correct. What is the probability when x will take value from 2 before 3?
By 4.
Why 1 by 4?
3 by 4.
3 by
3
4.
by 4, right? Why 3 by 4? Because we have to consider before 3, right? We are considering before 3. That means we have to accumulate. We have to add this probability plus this probability. So it's 1 by 4. It's 2 by 4. It's a 3 by 4. Okay. This is clear for everyone.
Yes, sir.
Now, what is about if x
But
is
we are, sir, for that, we are taking the value of x from 2 to 3, right? Not from 1 to 3.
okay? X is before 3.
Yes, sir.
X is before 3, right? Before
Yes, sir.
3 means what? F of 2.
Yeah.
F of 2 means what? X is less or equal to 2.
Oh yes.
Okay.
Okay.
So basically, this is the something standard procedure to writing down the all the values which was taken by the X. Okay. Now this is clear how we are getting the values.
I got it.
Okay. Okay. Great.
Thank
So yeah. So what about this before 4? So we have to add this probability plus this probability plus this probability. So what it will be?
7 by 8.
By 8.
7 by 8. Now we have only one thing, greater or equal to 4, right? So it should be
1.
so now you can verify also it's a PMF, correct PMF, because till 4 means we are adding the all the probability, this one plus this one plus this one and this one. So I got 1, correct? And CDF always lies between 0 and 1. CDF cannot exceed the 0 and CDF cannot exceed the 1. Okay, so how will we draw it? So to draw this CDF is nothing but, let's say
Stepwise.
okay, so this is the, let's say 0, this is the 1, this is the 2, this is the 3, this is the 4. So what are the probabilities? It's the 2.25. What is the 1 by 8? 1 by 8 is something point
0.125.
0.125, right? Don't go 1 by 8. Let's say 7 by 8. What is the 7 by 8? It's a 0.375.
Yes,
Not, it's a
0.875. 0.875.
So it's a 3 by 4 is something. 0.75
0.75. 0.75.
and 1 is 1 and this is 0.25. Okay, so accordingly we can do the scaling, right? So let's say this is 0.25. Okay, I mean scaling is not here perfect, but yeah, so just treat as, so this is 0.75. So this, okay, so this is 1. Okay, now before 1, x is taking value, CDF is 0, right?
Sir.
So before
Yes.
1 it's a 0.
Yes.
That means what? This is 0 before 1, right? Correct?
Yes, sir.
Yes, sir.
If you see, equality is involved from 1. Okay, so from 1 to 2 it's a 0.25. So from 1, since I have this is solid point, so 1 to 2 means before 2 it's a 0.25. Okay, it's the same for 0.25 from 1 to 2. Okay, now from 2 to 3, since the solid point is there as a 2, so at 2, so for 2 to 3 it's a 0.75. So 0.75 is there, so solid point is for 2, so 2 to 3 it's a 0.75, correct?
Yes, sir.
Yes, sir.
And 3 to 4 is 0.875, so just assume it's 0.875 is somewhere here. So from 3 to 4 it's a 0.7875, right? And
Yes,
from 1 from 4 onwards it's a 1, right? So it's a 1. X greater or equal to 4, it will be taking 1. So this is the graph of CDF. And one important thing, at every jump, correct, you will get the probability at a particular value. Okay, so what is the probability of x equal to 1? This is the jump, correct? This violet line. Okay, so this is, and this is not a line joined here. I am just indicating the jump here. Okay, it should be this okay, separate. What is the probability of x equal to 1? How much jump is there? 0.25.
Yes, sir.
So it's a 1 by 4. Okay, so how much jump as x equal to 2? 0.25 to 0.75. How much jump is there?
0.5.
0.5. That means
1
1
by
by
2.
2. How much jump as x equal to 3? 0.75 to 0.875. So it will be
0.125.
0.1.
0.125. 1 by 8.
0.1. Correct. Is it okay? Is it 0.875 minus 0.75, right? 0.125, right?
Yes, sir.
So it's a 1 by 8. How much jump is at x equal to 4? So 0.875 to 1, it's again 1 by 8, right?
Yes, sir.
So these values are same as the given in the table.
Yes, sir.
Okay, so we can get the PMF values from the CDF graph also. At every jump, it shows the probability. Funda is clear? CDF and graph of CDF.
Yes, yes, sir. Clear.
Okay. Okay, so tell me about this question number. First question. Which option should be correct?
Sir, it's asking wrong.
I mean, for that wrong, which
Okay.
options you have to choose as a correct?
Area under CDF.
Area under the graphs of CDF is always one is incorrect.
Okay.
So the answer should be correct. I mean,
Okay. It is always a step function, correct?
yes, sir.
As we have done, it's a step function, right? It's a jump. Step, 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 right?
Yes, sir.
And okay, let's
Maximum
choose
value
the
is
wrong
one.
options. Okay, this is the also correct because it's something increasing function, right?
Yes, sir.
I mean, suppose why it's increasing? What is the value of f of 2 here? Let's say f of 2 is 0.75, right?
Yes.
And if you take f of 3, so it's a 0.875. So if x1 is less or equal to x2, that means 2 is less or equal to 3. So f of 2 should be less or equal to 3, right?
Yes, sir.
So this is the this is the correct, but according to this question, this is the wrong option. Maximum value should be 1. It is always step function. Okay. Any other doubt in any of the question?
So no, there's question number 7 in the practice assignment. I have doubt in that. Also, if you can explain to us the infinite series, that would be great.
Question number
Infinite
7.
number, sir.
Question number 6 and 7. This one.
In infinite
This one?
series tutorial.
Infinite series tutorial.
Yes, sir.
I mean, if you can explain to us what infinite series is and how we can use this.
Okay, so infinite series. Okay, you know GP, AP, and all things. GP series and all things.
No, sir, I haven't studied that. My
Okay, so
11th and 12th
there is
is
some
valid.
formula. Okay, so you can explore. Just watch this tutorial also. Okay, so there are some formulas you can keep in your mind also. That will be helpful while solving the some questions. So some of the formulas is there. Okay, I will write down 1 or 2 formula. It's like, okay, suppose there is one series, something after putting the values, you are getting like this 1 plus r square
So
plus r cube and so on. Okay, it's taking like this value. Okay, means r is the less than 1. Less than 1 means suppose you are getting the, okay, so values for this one is the 1 upon 1 minus r. Okay, sum of this series. Suppose you got, after putting some value, you are getting 1 plus half square plus half cube and all things. Okay, so this is the this kind of series. Okay, so summation of this series would be 1 divided by
Sir,
1
here
minus r.
R is less than 1 means can it go below 0, sir? No.
Below
Zero. -1, -2 like that? No.
Okay, it can go for the series, but in case of probability, it will not be 0, right? It will not be less than 1.
Yeah, in case of probability, it will not be 0. Yeah.
So basic funda should be clear, right? It's something a ratio kind of things, okay?
Okay.
So here you will get value 2, okay? Like that. Okay, so there is one more formula, A plus AR plus AR square, like this, okay? AR cube. So you can search from the Google itself. You will get more formulas from there.
There was a question
And you
related to
can
this
watch
in
this.
practice assignment.
Okay, yeah, okay. We'll see that solution. And just watch this tutorial. That's why we have embedded one tutorial for the infinite series. Okay. So as you can see, suppose there are all the things has been explained here. Okay. This AARB as I have discussed. Okay. So these things. One example is also taken. Okay? Like this. So some things you can keep in your mind. Okay. Just watch this video. You will get clear idea. Okay. So you are asking some question. See, sometimes we provide the formula also. No need to worry about that. Question number 6, right?
Question number 6 and 7. Let's see.
Okay, if you get the 6, okay. Okay, so have you gone through the solution?
Yes, I could not understand the solution. I did understand the question. I mean, what the preface of the question is saying. But how to approach the question, that was something I could not understand.
Okay. So I have represented the solution. I will try to explain the solution so that you will get more clear idea. Okay. Now, so question is saying two friends, Ramesh and Suresh, wants to play book cricket game. Okay. Rules of the games are as following. Your initial score is 0 and you have maximum of 5 chance. Okay. This thing is clear. Now, you need to open a book page and the last digit of the right side page number will be added to your current score. Correct?
Yes.
So last digit of the right side page. That means if you get 0, you are out and you won't have any more chance to play again, even though your chances are not done. Means suppose you got 0 before the your 5 chances. Suppose you got 0 at 3, then you will not be play, right?
Yes, sir.
And the person who gets the highest score is the winner. This is clear. Now, question answers the book Ramesh and Suresh are using to play that contains 10 pages, that is numbered 1 to 10. Correct?
Yes.
With the right digit, right side pages containing the even numbered pages. That's okay because left side will contain the odd number pages and right side will contain the even number pages, right? It's saying assume there is an equal probability of opening for each page if the probability mass function for Ramesh is this and for Suresh is there. So what is the question say? What is the probability that Ramesh will not be out at the end of his chances? So Ramesh will not be out at the end of his chances. That means how many chances he have total?
He has 5 chances, right? To play. 5 chances to play. As long as he does not get a 10 in any of those chances, he will be not out.
Out. Okay. So what we have to consider? We have to consider since he is not out at the end of his chances. That means we should calculate the all the ways in which he can play, right?
Yes, sir.
And in which he is not out. Correct? That's only then he can play all the chances. Correct? Now, case one is like I can consider. Suppose I'm considering he is out in the first chance. So in how many ways he will be out in the first chance?
One way he opened.
One way, right?
10. Yeah.
10. Because score is what? Score is what we have to consider the as you can see in the question, we have to consider the right side digit, last digit of the right side page. Okay. So when I will get 0, if I got the 10, I have opened the 10 page, so I will get 0, right? This is the last digit of the right side page, right?
Yes, sir.
That means so case one is he is out in first chance, right?
Yes, sir.
So how many ways is there for this case? Only one way.
Only one way. He opens
Now,
10.
case 2 is there. He is out in the second chance. Correct?
Yes,
He
sir.
is out in the second chance. That means what? He is not out in the first chance and he is out in the second chance. Correct? So for being not out in the first chance, how many ways he has?
4 ways. 2, 4, 6, and 8.
Correct?
Yes, sir.
Just a second. Just a second. Yeah, sorry. Yeah. So how many ways he cannot be out in the first chance?
4 ways, sir.
4 ways, right? He can get 2, 4, 6, 8, right?
Yes, sir.
And for so 4 ways, okay, so not out in first chance and out in the second chance, right?
Yes, sir.
So 4 ways for being not out in the first
First
chance
chance.
and 1 ways for
Out in the
that
second chance.
correct?
Yes, sir.
So case 3 will be, suppose I'm considering out in the third chance. Correct? So out in the third chance means what? Not out in the first. Okay.
Yes.
Not I'm writing and not out second and
4 into
out
4
in the
into 1.
third, right?
Yes, sir.
So 4 into 4 into 1. That
1.
means 4 is square ways.
Yes, sir.
Similarly, case 4 means
4
out in
cube.
the fourth chance. Correct? So
Yes,
that
sir.
means not out in the first, not out in the second, not out in the third, and out in the first. Last, right? 4
Yes,
cubes.
sir. Yes, sir.
Okay. So same thing out in chance. Okay. So that means he is not out till the fourth chance and he is out in the fifth chance. That means 4
Yes.
is for 4 way. I'm saying not out after the fifth chance means he played and he wins all the 5 matches. So that means
Yes.
4 is for 5, correct?
Yes, sir.
Now, so these are the, so this is for the
Favorable
4th, this
cases.
is okay. So what we have to do, we have to consider we have to add all the cases. So you will get 1365, right?
So this is the part which I did not understand. Why we for the denominator, why we get 1365? Why we add
Okay.
all these?
Okay, why we are doing this? Because see, what is the probability basically? Favorable case,
Total.
case, total. What the probability has been asked? Probability is asking Ramesh will not out at the end of his chance. Okay, so probability Ramesh is not out at end of his chance, right?
Yes, sir.
This is the probability I'm interested. So I have to consider he is not out for all the cases, not out in the first, not out the second. I mean like that.
Okay.
Okay, we have to
Okay.
consider all the cases. This is the total case. Favorable is end of the chance means for the fifth case. When he wins he wins the game in all the 5 chances.
Hmm.
Is it clear?
Okay. Yeah.
Okay, now you got
Yes.
the idea.
Yes.
Okay, same you can do. Okay, so is there anything else? I think we have covered all the concepts, if I'm not wrong.
Sir,
Yeah, please go ahead.
sir, will it be possible for you to take a question from graded assignment?
Of which week?
Sir, this week.
No, before
It's
due
not,
date,
deadline
we
has not
can't.
been crossed, sir.
Yeah, that's why we can't. I mean, okay, so I can't do the whole solution kind of thing. I can give you idea if it's okay. but because the due date is pending, so before due date you have to do on your own. Okay, so just tell me which question. I can give you,
Question
if I
number
feel,
5.
I can give you a hint. Question number 5. Okay, that's okay. So it's saying a biased coin with the probability of heads is this. Let X represent the random variable that represent number of head runs. A head run being defined as the consecutive occurrence of at least two heads. Okay, so what? Okay, so X represents the number of head runs. What is the head run? When two consecutive occurrences of at least two heads, right? So it's saying and probability of single head is 0.75. Okay, if you toss the coin three times, how many possible outcomes you will get? Total eight. That means
Yes, sir.
you will get like this HHH, HT, right? THH, TTT, like that. Okay, total eight outcomes you will get. So it's saying represent the number of head runs. Okay, so what is head runs? You must get the at least two consecutive head. So if I'm saying HT, so is it head run or not?
Yes, sir, it is.
One head run, because this is not consider number of heads, head runs. So number of head runs is at least two consecutive heads should be there. So here one two so how many head runs is there? Only one. So X is taking one, correct? If your if you consider case THS, how many head runs is there? One, because two consecutive heads are occurring. If suppose I'm saying HTH, so is it head runs or not?
No.
Because two consecutive heads on are there. So similarly, you can think about for the remaining values. And probability for a single head is 0.75. So find out the probability of HST. Okay, that's all I can say so far.
Yeah, yes, sir. For HHH, sir, will it be 2?
Will it be?
Sir, for HHH, the X value will be equal to.
Yeah, your voice is breaking in between. Hello.
Yes, sir,
Hello.
you're audible. You're audible. Tanma's voice is.
Okay, so sees. Okay, so what is the head runs? Okay, let me explain this. As per in the question is also written occurrences of at least two heads. Okay, so consecutive occurrence of at least two heads. Okay, see, if written the HHS, that means it's only one head run. Okay, it's a one head run, because getting at least two heads is the head run. Okay, there is not any break in between, right? So I have written like this HSTHS, then there is two head run. One head run is this, at least two head run, two heads, and one head is this. So there is two. Okay, this is meaning. So I have written HHHHS. This is one head run. Okay. Is it clear now? Hello.
Sir, but possible ways of two consecutive heads are like, uh, here, sir, it will be like
No,
equal
no,
to.
okay. Don't consider this, this. This is not a meaning. What head run says, consecutive occurrence means simultaneous occurrence of at least two heads. If there is at least two consecutive heads, I will consider as a single head run. Okay. If there is like this, so you can't consider two head run. This is the one head run. Okay. Because there
Okay.
is consecutive occurrence of at least two heads. At least two heads means more than two, greater or equal to two. If I written like this, suppose I I toss the coin five times and I got this. So how many head runs is there?
Uh,
Two, sir.
Two. One head run is this and one head run is this. Okay. Tell me. HHTHS, how many head runs is there for this case?
Again, two, sir.
Again
Two,
two.
two.
If I written HT, how many head runs?
0.
None.
0. Okay, got the idea?
Yes, sir.
Okay, good.
Yes.
Anything else, or we can? I think there is.
Thank you.
Is it okay for you?
Yes,
Okay
sir.
then. Okay. So, is there anything else, or we can wind up? I think we have covered all the concepts, right? And
Yes,
some
sir.
questions.
Yes, sir.
Okay then. I think why is too very less people is there?
So
So
there
it's
is
very
another
late
session
notice,
going on right now.
Okay, maths 1 is going.
Yes, sir.
Oh,
and not
okay,
just that,
okay.
sorry, this was updated very late in the calendar.
Oh, yeah.
Yeah, there was
This-
some issue actually. Not kind of issue. There was some time availability issue. So
We've been
that's
having,
why.
sir, continuous sessions since 3 p.m.
Oh, okay. For rest of the courses,
Yes, sir.
and quiz 2 is on the next Sunday, right?
Yeah, back to back,
Yes,
we've
sir.
been having sessions.
I think that means you have to do a lot of hard work. Okay, then just
So how will be the these two questions will be? So I mean, will it be like something similar to the graded assignment questions that we are seeing here, or
yeah. You can assume this level of the grade assignment. Also, not exactly. You will. I mean, mock has been released it or not?
No, sir.
no, sir?
No. So when mock will be released, so you can think the same level of the mock, and I think syllabus will be from week 1 to week 8, with the major focus will be of week 5 to week 8, and some portion from week 1 to week 4.
Okay, sir.
Okay. Okay then.
Okay, sir. Thank you, sir.
Thank you.
Thank you, sir.
Okay.
Good time.
Thanks. Good night. Bye. Bye, everyone.